So at the end of the last class, we wanted to go backwards with finding a common denominator for fractions. And so before we do that, what I want to do is kind of review long division. So if we wanted to divide 6 into 121, I know this is a pretty easy question, but we would just want to make sure that we know how to do this still, that we remember how to do this. So we know that we have to ask how many times does 6 go into 1? It doesn't go in at all. So instead we're going to ask how many times does 6 go into 12? And we know that goes in twice. So what we're going to subtract here is this thing, these two things being multiplied. 6 times 2 is 12. So that's what we're going to subtract. And we end up with 0. And we bring down this 1. Now how many times does 6 go into 1? This thing. And we know it goes in 0 times. So what we'll do is subtract 6 times 0, which is 0, and we get a 1 here, and we can't pull down any more numbers. So this is going to be our remainder. So our solution here, if we take 121 and divide it by 6, we end up with 20 plus a remainder of 1. So we write that as 1 over the divisor, which is 6. So 20 and a sixth, really. And again, this is easy, but we just want to make sure that we're okay with it. So we'll put that in a square. Now if we do one more, let's say we want to divide 5 into 6,284. All right, so how many times does 5 go into 6? It goes in once. So we're going to take 5 times 1 and subtract that, these two. And so we subtract 6 minus 5, and we end up with a 1. Now we're going to bring down just the next number, which is 2. So now we want to ask how many times does 5 go into 12? We know that answer is 2. So we'll subtract 5 times 2, which is 10. We get a 2. Now we'll bring down the next number, which is 8. So how many times does 5 go into 28? It goes in a total of 5 times. So we're going to subtract 5 times 5, which is 25. We end up with a 3 here. And then we'll bring down lastly this 4. How many times does 5 go into 34? It goes in 6 times. So we're going to subtract 5 times 6, which is 30, and we get 4. Now there's nothing else to bring down. So what that means is 6284 divided by 5 is really equal to 1256 plus the remainder over the divisor, so 4 over 5. So 1256 and 4/5. And just to make sure that we're correct here, or if we're doing number theory or trying to write this quotient as a product, if we multiply both sides by 5, look what happens. We get 6284 is equal to 1256 times 5 plus 4. So we're able to write 6284 as 5 times something. And this is actually really useful when we don't have a remainder, because we can determine if it's divisible by that number by writing it like that. Okay. So the point last week, what we were doing was starting with a fraction. Well, 2 fractions. And if we tried to add them together, we had to figure out if we could find the common denominator and then do so. And sometimes we can actually cancel the fractions, but we didn't want to do that here. So for example, if we have x over x plus 1, and we want to subtract 3 over x plus 2. So in order to do that, we know that we would have to multiply the top and bottom by whatever part it doesn't have in the least common denominator. So the least common denominator in this case would be x plus 1, x plus 2. And so we'll multiply that first fraction by x plus 2. That's what it's missing over itself. And the second fraction, x plus 1 over itself, that's what it's missing. And so what we have here is x times x plus 2, that would be x squared plus 2x, over the common denominator. And then we're subtracting 3x, put this in parentheses because it's subtracting the whole thing, 3x and a plus 3. Again, make sure we keep track of this negative sign right here, because we're going to have a 3x and a 3, but we have to subtract that whole thing. Now in the denominator, we have x plus 2, x plus 1. So when we simplify it, we can write it as a single fraction now. We have x squared plus 2x minus 3x minus 3 over the common denominator. And we'll just simplify that a bit. So we have x squared minus x minus 3 over x plus 2, x plus 1. So that was algebra or pre-calculus. We've done it. So the question is now, if we only have a single fraction, can we write x squared minus x minus 3 over x plus 2, x plus 1 as the difference of two fractions? And even more than that, we want those fractions to have linear terms on the bottom, meaning degree 1, like we started with. And we know the answer to this is yes, we can, obviously, but we don't necessarily know how to do it yet. And for that, we use something called partial fraction decomposition. And it sounds scarier than it actually is. It's supposed to be at the end of pre-calc, but it's just not. For some reason, in a lot of schools, I think what happens is the curriculum's packed with a lot of stuff in pre-calc, and they end up running out of time. And that's pretty typical of what happens. All right. So yes, we have to use partial fraction decomposition. All right, so we have rules for this. We're going to write it out sort of as a theorem, and that way we can kind of just follow it, and we don't have to try to remember exactly what's happening in each case that we see it. So what we have is two fractions. One on top, we're going to call that n of x, the numerator polynomial. And on the bottom, we have the denominator polynomial, d of x, we'll call it. And we're going to also suppose that the bottom, the denominator, has a higher degree than the numerator. So the degree in the numerator, in the denominator, is larger or equal to, I think I said that backwards at one point. Okay, so what that means is if we have something like 1 over x squared, or 1 over x cubed, or x over x squared. Because if we think about it, if the degree on top is larger, then we can just simplify it, typically. Meaning if I have x cubed over x squared, I know that's just going to become x. There's not much going on there. But really, we don't even have to check for that, because we're going to notice it as soon as we try to solve the problem. So let's say we have 1 over x squared minus 5x plus 6. And we want to write this in its partial fraction decomposition. So notice that if we factor this thing, 1 over x squared minus 5x plus 6. It's going to be 1 over x minus 3, x minus 2. And so we can write that denominator as a product of linear factors. And again, linear means degree 1. So this means, since we have linear factors, we could write this as 1 over x minus 3, x minus 2 is equal to some constant, we'll call it a, over the first factor, plus some other constant b over the second factor. Okay, so now we need to figure out how we could solve this. And how can we solve this? Well, we just need to, again, find common denominator. So we need to solve for a and b. So I'm going to multiply both sides by the least common denominator, which in this case we know is x minus 3, x minus 2. So if we do that on the left, it's just going to disappear. And if we do it on the right, not everything's going to disappear, but a few things are going to disappear. Okay, so we have to, well, these are going to cancel and we're left with a 1. And on the right, we're going to have to distribute this. So we'd have a, x minus 3, x minus 2, divided by x minus 3. And then when we distribute it over here, we'll have b, x minus 3, x minus 2, divided by x minus 2. So look at the cancellation here. It's a factor that we can cancel, x minus 3, and then also x minus 2 over here. So we're left with 1 is equal to a times x minus 2 plus b times x minus 3. And if we distribute the a and the b, that's going to be ax minus 2a plus bx minus 3b is equal to 1. So if we simplify and we're going to factor out the x in the first term, it's really ax plus bx. So we could factor out the x. I'm going to put it on the right, it doesn't really matter, but so again, if we have ax plus bx, we could factor out the x and then we'd have a plus b, but remember it doesn't matter if we put it on the left or the right. So I can really write this as a plus b and just write the x on the right hand side. And I'm going to do that for a reason. And then what else do we have here? We have plus, I'm going to write a plus, and then we have that negative 2a and that negative 3b. So since they don't have any x attached to them, I'm going to put them together in parentheses. And that's equal to 1. We can do this in a few different ways. We could just let x be some number and go from there, or let a and b stand as they are and try to solve it, which I think we should do that when we have a little bit more complicated of a problem. So we'll probably do that on the next one. So substitute some value of x. So let's say x is equal to 3. If x is equal to 3, we'd have 1 is equal to a plus b times 3 minus 2a minus 3b. And what we have now is 3a plus 3b minus 2a minus 3b, and that's still equal to 1. And if we simplify, look what happens. The b's are actually going to cancel, and we're left with one single a there, 3a minus 2a. So we get a equals 1. All right. So if a is equal to 1, we can find b pretty easily. So we'll find b, and all we have to do is substitute. So 1 is equal